This record is about reading, view reading. In the analogy, say daily life language and graphical language. Well, engineering drawing is a language, using the views of an object and of course associatively showing the dimensions, can explain shape and provide the size info. Okay, for the interest of the person in general can say that reader. Yes, this is an engineering drawing. Okay, to explain the shape of a single component and also inform the reader on the size. For informing the reader on the size of the features of an object, we use special dimensioning format. Okay. If it is a language, yes, engineering drawing is a language, then it should have an alphabet, and it should have at the learning stage writing part, okay, and also reading part. Okay, writing, reading, alphabet, and of course the grammar of the language. Okay. Today, for a few years, actually, since 1989, yes, engineering drawing method is an alternative method, okay, to use for explaining, describing the shape of an object and providing the size of the features. This is in the example in AutoCAD environment, the necessary views, orthographic views of an object, and of course together with the dimensions of the features. And saying an engineering drawing, the classification, we mean either assembly drawing or detail drawing. If the views are for explaining the shape of a single component, then say in general the sheet on which we have the necessary views of a single component and the dimensions, and of course the other things in the content of title block. And you see here we have some annotations, okay, all of those things. Together with all of those things, if on the page we have all of such things, then we say that it is a detailed drawing. The other engineering drawing in the classification is assembly drawing. If the object is an assembly, then the page on which find the views of the assembly and the overall dimensions and the identification numbers of the constitutive components and the parts list, okay, as attached to the title block, where reader can find the names of the components, and along the notes column of parts list, reader can see the technical notes on the for the standard components. Yes, it is called assembly drawing. Since 1989, engineering drawing is an alternative description method. The other description method is, today, solid modeling. For instance, here we have the solid model of the object. There, in AutoCAD, for that object, the engineering drawing. Yes. Engineering drawing at the reading stage requires education. The reader should know the meaning of some standard symbols, special symbols. For instance, here at the title block, you see this symbol to say that the selected quadrant, okay, for the given orthographic views on this page is the first quadrant. You know, picture planes divide the universe in orthographic projection. We consider that there are three primary principal picture planes. They divide the universe into 8 quadrants. Okay, for engineering drawing purpose, either we use the first quadrant or the third quadrant to imagine the object as located in the space. And then the rest orthographic projection. Actually, you learn all of such things, okay, thanks to your studying on the content of this course, MEC 113. Now here this video record, well, I want to focus the attention to the method of reading. Actually, it is my method, okay. I strongly recommend that method, okay, at the view reading stage. Saying view reading, we mean what? Well, actually, reading in the daily life language analogy, say with the daily life language analogy, say that you have a sentence and then read the sentence. If of course the words along the string have been written at the correct places, okay, well, actually the grammar of a language is for that purpose. For each specific words, okay, we use standard places along a string. If the writer write the words at their correct places, then the string, it is a group of words, okay, will be a sentence. Well, if the person, he or she, knows the alphabet of that language and the grammar of that language, okay, looking at a sentence, then expect that that person can achieve reading. Okay, read the sentence and understand what does it mean. If the experience of the reader is good enough, looking at the sentence, well, easily, almost immediately achieve reading, can read the sentence. Actually, experience comes from writing stage, okay? While learning a language, after, of course, passing through alphabet learning stage, then we deal with writing exercises. Write letters, write thereafter words, write sentences, write paragraphs. Okay, while studying on the writing part of a language, inherently, naturally, someone can learn the reading part. Okay, in time, be ready to achieve reading. Of course, if writing exercises are, say, sufficient at the language learning stage, then, well, someone can much more easily and quickly achieve reading. Well, in the method of today, it is solid modeling. Well, reading does not require any education, because today the solid model environment, Inventor, for instance, is one of the software where reader can find, thanks to the creation stage, of course, the model of an object. If the material for the created model has been input, okay, then, well, instead of saying model, we say solid model. Well, solid model is as if real in the virtual environment. So, well, someone using the tools of the software, for instance, I clicked on orbit button, and then what I am doing, rotating the model in the space to be able to understand its shape. At the back side, what is the geometry? well, what are the entities at the top side, at the left side, right side. Okay, anybody, even a children, if that person is allowed to see the object, the model of the object from all the necessary directions, points of views, then yes, well, even a children can understand the object to its shape. And today, you know, in such environments, it is possible to show the dimensions. Select annotation, tab, and then well, clicked on dimension button, okay, and then show the dimensions. For instance, indicate this one, and then show the dimension in 3D space, okay, and then show this one, and then, well, program brings the size of that feature, okay, indicate this circle, and then well, its diameter is added. Yes, it is possible to inform the reader in such a 3D space on the shape and on the size. It is actually the best method of description today. But although it is so, still majority of the people, the old engineers and architects especially, still keen on using engineering drawings. Not the solid model, but they preferably use orthographic views, engineering drawing sheets. So in MEC 113, considering that, well, today solid models are used and also engineering drawings are widely used for this description purpose, then, well, you know, some chapters aim to educate you on engineering drawing, the others solid modeling. You learn both of them, I hope, and ready to take the final exam. Reading, saying reading, we mean looking at the views, read an engineering drawing. Okay, what does it mean? Well, look at the given orthographic views, okay, and also see the associated dimensions, and then, well, start seeing the object in your mind three-dimensionally. If you can imagine the object in your mind, simply looking at the given views on such a sheet, and then, well, in time you start seeing the object like this, this means you read the given engineering drawing, read the given views. Okay. View reading requires knowledge and also experience. Okay, especially while on the writing part. Writing in engineering drawing, saying writing, we mean view drawing. If the software is two-dimensional AutoCAD, well, you know, the thing to do is very similar with the things in hand drafting. In hand drafting, to be able to draw, for instance, this view, this projection, using the rules and the T-square and mainly a pencil, okay, we draw the lines. Moving the point of the pencil, okay, along the edge of ruler or T-square, we draw straight lines. For the circles, we use compass. Today, in using the 2D part of AutoCAD, the things are very similar. Instead of using a pencil for straight lines, you know, we clicked on line creation button. For circles, clicked on circle creation button. Okay, already studied on such things. Well, drawing the projections, of course, if on the page there will be not only one view, but two or more views, then you know the reason. In orthographic projection, well, between the views, we have a geometrical dimensional relationship. Yes. Why? Because in orthographic projection between the picture planes, we say that we have coordinate axis, either x-axis, z-axis, or y-axis. Between the frontal picture plane and the horizontal picture plane, we say that along the folding line we have the x-axis or the Cartesian coordinate system. Between the frontal picture plane and profile picture plane, we say that we have the altitude axis, z-axis, and between the horizontal and profile picture plane, consider just as coincided with the folding line between the picture planes, the y-axis. Since the adjacent views use the same coordinate axis, mathematically speaking, can say that it is obvious that front and the top are related views. Top and the left side or right side are related views. Front and the left or right side related views. Okay, these are dependent to each other because they use the same coordinate axis. But in engineering drawing, well, to be able to have the views consistent with each other, at the background what we have, at the view construction stage, lots of transfer lines. Well, allow you to see the transfer lines, you know how. Well, use the filtering technique. As the visibility of the things in the layer, what we have the transfer lines. You know how, turning the length of that layer in the analogy. Okay, transfer lines, I am sure in this layer I have the transfer lines. These are the straight vertical or horizontal lines. Okay, to have the views consistent with each other, to have the views, okay, respectively for the same points, to have the same abscissa, same ordinate, same altitude values. Yes, now this straight lines, after asking the visibility of the content of transfer line layer, they are in the screen. Well, these are the lines to have the views consistent with each other. Okay, and also to be able to mark them, mark the characteristic points on the picture planes. While of course over the surface of drawing paper we have the regions. Okay, those regions corresponds to the surface of the picture planes. Well, for instance, my cursor is moving around this projection. That region corresponds to the surface of what? Surface of this picture plane, frontal picture plane. Okay. This part, now my cursor is moving around the view, corresponds to the surface of profile picture plane. And this part of the paper, okay, is allocated to the surface of horizontal picture plane. Since between the views we have the x, y, z axis, obvious the views must consistent to each other. While drawing the transfer lines, creating the transfer lines, at the intersection of transfer lines, we have the images of the characteristic points, terminal points of the straight intersections, center points of the circles, okay, tangent points, etc. Well, on this view, on the adjacent view, on this view, on the adjacent view, on this view, on the other side view, well, having the same x, y, z coordinate values respectively. So can say that views are consistent. And also for each view we have specific locations on the paper, on the drawing sheet. It is just in the similarity. The grammar of a language says that, for instance, ejective, say subjective, verb, adverb, for each word we have standard places along a sentence. So well, if writer and reader obey to the rules of grammar and correctly write the sentences, then reader, he or she knows the same language, his or her experience good enough, on sentence writing, and the reader, he or she knows the alphabet of the language, grammar of the language, then while looking at the written things along a sentence, then reading is achieved. Similarly, in engineering drawing, everybody should know that this is the front side view, this is the top side view, this is the left side view, and so on. Well, if they have been constructed and then completed using the coordinate values of the characteristic points as the same on the adjacent picture planes, and the views are at their correct places, then person can be expected that he or she can read the given views and imagine the object in the mind three-dimensionally. View reading, in short, what I mean, is learned naturally, inherently. Starting from the alphabet of the language, learning stages on alphabet. In engineering drawing, saying alphabet, we mean different line types. Thick line, what is the meaning? Thin line, what is the meaning? Long dash, short dash, what is the meaning? Extension line, dimension line, visible outline, hidden line, cross-hatching line, transfer line, construction line. Yes, using those lines, while we construct, we have the projections. If the reader knows the meaning of different lines, then looking at the images and finding the views as their correct places, and also while knowing the meaning of special symbols. For instance, if you know what does it mean, you see there is a symbol, then can understand, thanks to the existence of such a technical node, okay, what is the indicated feature in shape and in size. Yes, dimensioning part also is a hint at the view reading stage. Okay, well, view reading, in short, requires education. The education is to be on the alphabet, okay, and experience on the writing part, and of course, well, the meaning of technical notes, specification notes, and well, some symbols. Okay, if the person knows all the things on the meaning of symbols and the dimensioning format and the grammar of the language, in other words, orthographic projection, you know, orthographic projection is the grammar of the language. Well, if the reader, well, bring the famous example to the screen one more time. Well, find the presentation and then the slide where have the example. Well, trying to find my presentation. Yeah, that is the file. Open it. Yes, this chapter and my presentation has already been subjected deeply, sufficiently under this title, Orthographic Projection Principal Views. And then see this example. Yes, object has been located in the first quadrant, and after having the images of the object on the surface of picture plane and rotate the picture planes in the standard directions, obtain the principal views at their standard locations. It is just like the grammar of a language. For each view, we have specific standard locations. If the views have been drafted, okay, have been shown at their standard locations. For instance, if view drafter at the writing stage, view drawing stage, okay, drafted the left side view at its correct place and in the relationship with the front side view, it must be so because between the front and left we have the commonly used Z-axis. Yes, as it can be seen here, the folding line coincides with the Z-axis of the coordinate system. It is between the frontal picture plane and the primary profile picture plane. Okay? On which in the first quadrant projections we obtain the left side views. Okay, this is in general speaking profile, but which profile? Primary profile picture plane, PP. Okay, this is the primary frontal picture plane. This is the primary horizontal picture plane. Okay, that one. Secondary is secondary horizontal picture plane. SH, I mean secondary horizontal picture plane. This is the secondary frontal picture plane. This is the secondary profile picture plane. On the primary frontal, primary horizontal, primary profile picture planes respectively, we obtain front, top, left side views. On the secondary picture planes, well, on the surface of this picture plane, the right side view, on the surface of that picture plane, back side view, on the surface of this picture plane, the bottom side view. And then rotate the picture planes in the standard directions, and on the page be ready to draw the images at their standard locations. We obtain the images relative to each other at those standard places. If writer at the view construction stage, okay, constructed the images at their correct places and in shape correct, in size correct, and using the coordinate axis between the front and the top, we have the x-axis, you know. Between the front and the left, we have the z-axis, okay. Between the top and the left, we have y-axis. Yes, although in the space y-axis is unique, here it is along the folding line between the primary profile and primary horizontal picture plane. While we are rotating the profile and horizontal picture planes, okay, y-axis is attached to the horizontal picture plane and it finds its place as vertically oriented in the down direction. But if the y-axis is attached to the primary profile picture plane, it is traveled together with that picture plane. Y-axis finds its place as horizontal oriented to the right, extended to the right. Okay, so well, already studied on such things. Obvious that from here, well, in drawing front view, we use abscissa altitude values. Drawing left side view, ordinate altitude values. Drawing top side view, abscissa ordinate values. Yes, we have such a coordinate system. So if the drafter has been drafted the views while using such a coordinate system via marking the images of the points respectively on the adjacent views to have the same abscissa, same ordinate, same altitude values respectively, and the views are at their correct places, then this means it is like a sentence. Well, the other person, okay, can achieve reading. Of course, he or she knows the same language, can distinguish that which one is front view, which one is top view, which one is left side view, and also reader should know the dimensioning format and the meaning of technical symbols, technical text, technically written text, notes. Well, then reading is achieved. Okay. Transfer lines, yes. In my method, view reading method, transfer lines are one of the main tool. One of the main tool in my method is transfer lines. Okay, transfer lines. Using the transfer lines, views can be constructed correctly, and following the transfer lines at the view reading stage can much more easily achieve reading and start visualizing the object in the mind. Actually, after this video record, I'm going to give an example, okay, and then, well, you're going to see clearly how the transfer lines are used at the view reading stage. Okay. In my method, the other tool actually, well, today is a tool. If you have Inventor, for instance, new generation software, you know, today, after creating the model of the object, for instance, here, we have the model of the object. And then, well, create the views. Today, not drafting, but using the tool of such a, say, software, 3D modeling and design software, you know, clicked on this button, and then, well, you learn the method procedure, select unit system, select the paper template option to have a paper simulation, and then, well, clicked on this button, and then teach to the software you're going to create which side view. Okay, front side view, clicked on this, left side, the top side view, clicked at such a place on the paper, make a click at such a point, and then, well, teach to the software that over there you're going to create the left side view, and then say OK. Yes, today, if you have solid model software and you have the solid model of the object, well, views can be created even in few seconds. Well, the other tool in my method of reading is that one. Well, have a look at the given views and then say something on the shape of a certain selected feature. And then create it as view, create it as model, and then the views. If you can obtain the same views as they have been shown on the given sheet, then this means your reading is correct. Okay, I'm going to clarify this part of my method during the CAD application part. In the second video record, following video record, you're going to see what is my method, how I use transfer lines, how I use model and thereafter view creation tools to achieve reading. Okay. Well, after saying such things, view reading requires knowledge on the alphabet and experience training on the writing part, view drawing part, and well, the knowledge on the dimensioning format and the meanings of some standard symbols and technical notes and annotations. Then yes, to say that, well, up to this time, studying on the types of lines and then studying on one side views and then more side views, multiple projections, and well, learning the dimensioning format, can say that you are ready to achieve reading. Okay. I'm going to bring thereafter, after this stage, some starting from very simple reading exercises or reading cases, step by step, increase the difficulty level, and then I hope can take your verification that yes, you are really ready to achieve reading. Okay, start. Yes, say that it is the case, you found such a projection, okay, such a projection on the page, and then the thing to do is that look at this view, how many views are there on the page? Only one view, and then achieve reading. Look at this image and then visualize the object three-dimensional in your mind. Can you achieve reading? The answer, I am sure, yes. Why? How? Well, although at the title block, the famous symbol, you know, first quadrant symbol or third quadrant symbol, if the quadrant is the first, at the title block, this symbol is shown. If the quadrant is the third, that symbol is to be shown at the title block. Here in this example, although at the title block, the quadrant symbol has not been shown yet, but still can achieve reading. Well, before saying something on the shape of the object, then first see the title block and then over there find the quadrant symbol, whether it is first quadrant symbol or third quadrant symbol. But here in this school exercise, well, there is no quadrant symbol. Why? Because teacher aims to test the learning outcome, whether although quadrant symbol has been hidden, has not been shown, whether student can achieve to say that it is a first quadrant projection. How? Well, here at that stage, dimensioning learning outcome on dimension format will help you. You know, in accordance with ISO standards, ISO rule, dimensions are shown above the dimensioning lines and always in alignment. You learn this. So, well, you see these dimensions, these numbers have been shown above the line and in alignment as parallel to dimensioning line. This means it is in accordance with ISO. Since it is in accordance with ISO rule, this means the quadrant is associated with the first quadrant. If it is first quadrant and the dimension have been shown in accordance with the rule of ISO, then no doubt these dimensions are in millimeter. Unless otherwise specified at the legend or title block, then in the first quadrant projection we use millimeters. So unless otherwise mentioned, all the numbers shown as the dimensions of the features are in millimeter. In third quadrant projections, the dimensions are in inch, but not in inch but in foot. Then it must be mentioned at the title block, well, a short notes to say that dimensions are in inch, are in not inch, are in foot. First quadrant projection, if the dimensions have been shown not in millimeter but in centimeter, then since it is contrary to the common convention, well, the unit of measurement is to be written at a certain part, preferably at the title block of the technical drawing sheet, saying that dimensions are all in centimeter, for instance. Okay, and the other thing, well, after saying that it is first quadrant projection, then, well, that question may be asked. Okay, then it is which side view? There is only one view, but it is which side view? Front, top, left, right, bottom, back, which one? You have already learned the answer of such a question. Remember, if there is only one view on the page, then it is no doubt the front side view, because front view is not optional, is not eliminated. All the cases, front view is to be shown. If only one view is enough to explain the shape of an object, then yes, it must be front side view. So this is the front view of the object. What I am doing, you see, passing through the stages of reading. First, I perceive the quadrant and then said that it is the front side view, and then, okay, then what is the geometry? Well, in answering this question, actually on this view there are two hints. The main hint is the longitudinal axis. Well, as the figure, we have a rectangle, but on the rectangle we have long dash, short dash. You have already learned the meaning of this line. It is to say that axis of symmetry. On the views of which features, which objects we show such an axis, you know the answer. If the image is the lateral side view of a revolved object, we show the axis. it is called longitudinal axis. Well, longitudinal axis is shining to say that it is the image of a revolved object. Okay, the revolved object is cylinder or a cone, truncated cone. If there is only one diameter value, yes, at this point the standard symbol, it is from Greek alphabet. Okay, this symbol to say diameter, phi, letter phi from Greek alphabet to say that diameter. The following number is the diameter. This is the diameter symbol. In ISO format, we use this symbol to say that the number is diameter. Well, you see here, diameter is 27 millimeters, and on the paper, only one diameter value has been shown. Well, at the other side, you see there is no diameter value. This means it is a cylinder. If it were conical object, then at this end, the diameter shown, and at the opposite end, the other diameter had to be shown. Since there is only one diameter value for the description of the object, this means no doubt it is a cylinder. And then, well, you know, this vertical distance is delta z, and delta z is the height, means height of the object. This is the front view. Okay, diameter of object is a cylinder. Diameter of the cylinder is 27 millimeters, and the height of the cylinder, length of the cylinder is 50 millimeters. That is it. And then the rest, bring the object in your mind and start seeing the object to your mind eye. Yes, I see that it is a cylinder. You see, reading achieved. We achieve reading. But how? Well, regarding the meaning of this symbol, regarding the meaning of this line, and remembering that if there is only one view, it is the front view, quadrant, first quadrant, etc. And then, well, start seeing the object three-dimensional in the mind. Yes. Well, if the reading is the one, that reading stage, well, can be finished or completed in even few seconds, then I'll say direct reading. Have a look at, and then almost immediately start seeing the object in your mind. Well, for basic geometries, it is possible. Have a look at the image of the object. It is in basic shape. Then, well, almost immediately say that it is the geometry, it is the shape of the object. Okay, then another example, step by step, increase the level of difficulty. Now here there is again only one view on the page. No doubt it is the front view. Here the quadrant symbol has not been hidden. It has been shown. Yes, always the quadrant symbol is shown on the paper at the title block. But in school, teacher may hide it to test whether, although it has been hidden, student can achieve reading, can say something whether the quadrant is the first or the third. If quadrant symbol has been hidden, then simply considering the dimensioning format can say either it is first quadrant or the third quadrant. If the dimensions have been shown over the dimensioning lines, this means it is the third quadrant projection. You know this. Okay, here at the title block, yes, quadrant symbol is the first. Looking at the images and regarding the written things in the content, well, achieve reading. For instance, for this object, well, it is geometry has been explained on the sheet, and also dimensions of the object have been shown. What is the material? The object is to be made of which kind of material? Well, this part also, well, included to the view reading. How you can learn the material of the object? Yes, in general, looking at the title block, one of the pigeonholes of the title block is allocated for that purpose to inform the reader on the material of the object. And the box is entitled with this word material, and the standard code, it corresponds to a certain commonly used material. In industry it is used. Well, we inform the reader that it is made of this type of material. Here, this code to say that aluminum alloy. And the code of the document published by Standardization Association is 6061. The details can be found referring to that document. It is about that alloy, and it has been published by one of the Standardization Association. You learn all of such things. And then yes, this is the front view of a cylinder. No, because there is no longitudinal axis. If there is no longitudinal axis, this means it is a rectangular prism. How about the size of its cross section? Now, on the answer of this question, we have a meaningful symbol. It precedes the number. It is the square symbol, and it is to say that cross section of that prism, it's a rectangular prism, is a square. So prism is a square prism. And the size of the base size at the cross section is 50. Since it is square, 50 by 50. Unit of measurement is millimeter. Okay. The height of the prism is 100 in this example. So the rest, visualize the object in your mind, three-dimensionally. Well, to test whether your imagination is correct, actually, if still you have a doubt, say that whether your reading is correct or not, then well, you can open Inventor and create the model of the object. Okay, in the shape, passing to the reading stage, you said that it's a square prism, and also seeing the given dimensions, said that it is in that size, and then create the solid model, and then check whether for that solid model, when you created the view, obtain the same result. Okay. Another example, reading example. Okay, now in the order, bring this sheet to your interest and then say that achieve reading. What is the object in shape and also in size? If there is not one, but there are more views, in this example 2 views, yes, the quadrant symbol is extremely important. The first thing to do is that refer to title block and then see which quadrant has been selected for this orthographic views. In this example, you see the symbol is shining. Quadrant symbol. Which quadrant symbol? It is the first quadrant symbol. Yes. Since it is the first quadrant symbol and you learn already studying on such examples and listening me, watching the video records, reading the books, attending to the class meetings, etc. You know that the only view is that it is the front view. Below or above the front view can have another principal view. Well, here, if there are 2 views on the page, unless otherwise mentioned, one of them must be front view, and then the other one, bottom side view or top side view. Okay. Now, in this example, well, it is the first quadrant projection. Well, the view at a higher level is the front view, and the lower one is the top side view. Front, top. And the views are consistent with each other. In Inventor environment, after bringing the cursor to the vicinity of the base view, the first created view, and then make a click, then between the views find a joining line. It is the indication that the views are consistent, correctly created. Okay. In 2-dimensional drawing or 2D AutoCAD drawing, Well, using the transfer lens make the views consistent. In Inventor, clicking on the base view creation button only one time at the beginning. For the others, projected button. Actually, projected button is clicked on by the software while we are creating 1, 2, 3, 4, maximum 5 principal views at the background on behalf of us. So the views created as consistent views with respect to each other. You know this. Well, after seeing that here, this is the front view, this is the top side view. And then see what is the front view in shape. It is a rectangle. What is the, say, figure in shape, projection in shape? It is a rectangle on the top side view. So front view is rectangle, top view is rectangle. From your experience and studying at the writing part, if you create the views of a rectangular prism, you obtain two rectangles, top, front. Yes, if there were one more view, it is going to be again a rectangle. So both of the views are rectangle, and two views are sufficient to describe the shape of the object. This means no doubt object is a rectangular prism. Okay, then you said that rectangular prism, yes, it is correct. That is the shape. How about the size? Create the model of the object. But in which size? Well, the answer comes from the learning outcome on the dimensioning format. And also orthographic projection. Between the front and the top, we have the x-axis. And delta x is the width of the object. Yes, 64 is the width. Okay? And 39 is the height. 34 is the depth of the object. So gather the dimensions looking at the views. Okay, finding the size of the features referring to the given views, the views shown on the page, then be able to see the size of the object. Which one is the width, which one is the height, which one is the depth. And then accordingly, if you're going to create the model of the object, such as in Inventor environment, be able to create the views, create the model in Inventor in the correct shape and in the correct size. And after having the model of the object in Inventor, when you created the views and shows the dimensions, if you obtain the same result, the same views with the same dimensions, this means your reading is correct. Well, to be able to achieve view reading, I said, well, the views are to be drafted at their standard places. But in civil engineering, architectural drawing, well, if the object is a little house with a single flat having one floor, it is okay. You can show the front view, top view, first quadrant projection, top view, bottom side view, left side, right side view. But if the object is a building, not a cottage, but a building, then, well, see the problem. I have already talked about this difficulty of architects at the view drawing stage. For instance, here in this example, you see building has one basement floor, first floor, second floor, third floor. There are 4 different floor plans, different top views. But theoretically, we have only one place for having only one top view. Although, in the case of architects, say that object is a building or even a skyscraper, not one floor plan view, but say that 4 plan views, 5 plan views, and plan views. How the plan views are shown on the page drawing sheet? Well, it is the convention of architects. Just architects breaks the dimensional relationship between the front view and the plan view, front view and the elevation view, and then arbitrarily draw the plan views side by side. You see, this is the basement plan view, this is the plan view of the first floor, this is the plan view of the second floor, and so on. Although architects break the link between the views and draw the views of the buildings at arbitrary places, well, conveniently or conventionally side by side next to each other, since the geometry of the object in say architectural applications, so correspondingly civil engineering applications is very simple. What is that? It's a rectangle. So although the geometric relationships between the views have been broken by the drafter, well, reader can achieve reading. Why? Because have a look at. See this plan view. What is the geometry? It is a rectangle. Can you imagine the room in your mind? Although this plan view has not been shown in the geometrical relationship with the elevation view, with the front view, with the backside view. The answer is yes, because figure is a very simple figure in shape. So thanks God, the geometry of the buildings, house, are very simple, rectangular prism most of the cases, and maybe cylindrical in shape. Okay, although the views are not consistently drafted on the page, obeying to the grammar of the language, okay, obeying to the rule. What is that? The principal views are to be at their standard places on the page, while reader can achieve reading because of the simplicity of the geometry. Okay, well, this is the plan view. This is the east elevation. This is the west elevation. This is the south elevation. This is the north elevation. While looking at the elevation view, in theory, in general, say that front side view, reader can see the altitude values. Looking at the plan views, reader can see the delta x, delta y values. And then, it is in which shape? It's a rectangular prism. So in the mind, reader can start visualizing the building three-dimensionally. Okay, in the applications of architects and the civil engineers, live at the view reading stage, even though the geometric relationships have been broken on the technical drawing by the architects, at the reading stage, life relatively easier for architects and civil engineers. But mechanical engineering applications, then the object may not be, of course, in rectangular prismatic shape. It may be even a very complex geometry. And the only thing to do in case the object is complex in shape, have the views, draw the views, create the views at their standard locations. Never break the link between the views. Reader, okay, should be able to find the views at their standard locations. Okay, so much more easily pass through the reading stage. Okay. Another example on reading. Yes, this one. More than one view, so which one is true? Whether this is the front this is the left, or this is the right. You know, if there are two views on the paper, those have been drafted side by side, no doubt one of them is front. But the question is on the other side image. If it is first quadrant projection, okay, the view, now my cursor is indicating the view, it is over there, going to be the left side view. But the quadrant which has been selected for the necessary orthographic projections, they are to be used for describing the shape of an object, is the third quadrant, then that view will be the right side view. So the question, whether it is left side or right side view, which one is correct? For non-symmetric objects, it is important to know which quadrant has been selected for the given orthographic views. So I say the same thing. First, refer to title block and then see the quadrant symbol. Here it is the first quadrant. Okay, if it is first quadrant, then this view, no, that is the front view and that view is the left side view. On the front, on the left, well, the outer figure is rectangle, rectangle. So, well, that the main body is a rectangular prism. Okay, and then if there were dimensions, yes, it is not optional actually. The dimensions are always shown. Yes, show the dimension. Say that this is the width. Show this dimension. This is the height. Show this dimension. This is the width, depth. Okay, then can see the size. But you see here on this view and the other side view, we have dash lines. Yes, you know the meaning of dash line. In general, dash line means the feature is hidden relative to the reader. Well, here we have a hidden rectangle on the front view, and this hidden rectangle, if we follow the transfer lines, yes, here and there, if you want now, take a print screen and then paste it in Paint program to draw the transfer lines. Okay. Yes. You know, between the front and the top, what we have, views, we have the altitude axis. This is the z-axis. Try to draw. Okay, then use text facility. Okay, this is the z-axis. Yes, z-axis. Since the z-axis is commonly used, okay, by both of the views, then, well, the altitude of all the characteristic points at this level and the altitude of all the characteristic points at that level, in other words, delta z value between them, must be the same here and there because the axis is the same axis. So, well, see this fact, remind you. You see the front view is between this transfer line and that transfer line. Since the z-axis is commonly used, if the front view of the object is between this and that, those transfer lines, then it is left side view must be between the same transfer lines. You see at the view reading stage, following the transfer lines, between them we have the image of a certain feature, and finding correspondingly at the other side on the other picture plane the image of the selected entity, can say something on its shape. Well, between this transfer line and that transfer line on the front view, what we have? We have a rectangle. That is the rectangle here. And well, between the same transfer lines on the left side view, yes, what we have? We have another rectangle. Rectangle, rectangle. So this means the main part of the object is a rectangular prism. Okay. How about the hidden part? Yes, similarly, the front view, on the front view, yes, between this transfer line and that transfer line, yes, what we have? We have a hidden rectangle. And between the same transfer lines, this and that, on the other side view, it is the left side view, we have another hidden rectangle. So if two views are sufficient and on both of the views we have, as the image of the feature, we have rectangle, then this means it's a rectangular prism. But here be aware, this is the detailed drawing of a component. It is not an assembly. Object is a component, not an assembly. So if it is a single component, in real world, it is impossible to have a solid body within the same solid body. It is impossible to have another solid body within the same solid body. In real world, it is impossible. So outer one is a solid object, solid part, and it is a rectangular prism in shape. Within that rectangle, can we say that another solid rectangle we have, rectangular prism? No, impossible. But there is a rectangle here, rectangle, this means feature is a rectangular prism. What is that? It's an empty space. Yes, we have a solid rectangular prism, and within the solid rectangular prism, we have a rectangular prismatic empty space. Yes, don't forget, if the view is the view of a single component and within the area of the view, over the view, we have a hidden feature, then this means it is the image of course, if after saying that, looking at the adjacent views, say that it is, for instance, a rectangular prism, then what is that? On the front view, it is at the inside. On the left side, it is at the inside. So obvious that the entity, this entity, hidden entity, is an interior feature, not an outer feature. So it cannot be solid extension. It must be an empty space. Okay? For instance, on the left side view here, as the image, okay, if there were such a part, okay, not this hidden rectangle, but instead of having a hidden rectangle on the left side view, if we had such a rectangular, visible rectangle, then I would say that this means at the back side of the object there is a rectangular prismatic extension. That's its front view. Since it is hidden, it is in dash form, and on the left side view it is visible. But here you see it is the case, not an exterior feature in our case. Yes. Oh well, sorry. In our case, not an exterior feature. The hidden entity is an interior entity. So since it is at the inside, it cannot be solid feature. It must be an empty space. So well, making such an interpretation, of course, can do it knowing the ABC of orthographic projection and saying that this is front view, this is left side view, can conclude that yes, within the rectangular prismatic object, there is a rectangular prismatic empty space. Now, see it is model. For this description, that is the corresponding model. Okay. It is a rectangular prism, and within the rectangular prism you see there is an empty space. It is in rectangular prismatic shape. Yes, there is such a cavity. Blind rectangular prismatic space, empty space. Okay? So while observing the object in this direction, it is hidden. While observing it in this direction, it is hidden. Yes. You see, achieve reading. Another example, this one. Is it easy to read? Once having a look at, can you immediately say something on the geometry? Well, if the object is the one, it has not 1, 2 features, but more features. Okay, so can say that its shape is relatively difficult, complex. Then having a look at the views, well, such a case, we cannot visualize the object in few seconds in the mind. It takes a certain time. And well, for complex geometries, the second tool of my method comes to the stage, and well, say that if you know my method at the view reading stage, you can achieve the reading much more easily when using a shorter period of time. Well, not this video record, but the following video record, I'm going to give an example, selecting not a simple geometry, relatively more difficult one. For instance, this one. The given orthographic views. Yes, achieve reading. In my method, the one tool is transfer lines, the other tool just model creation. Okay, for in sequence for each constitutive features. I'm going to make the sentence clear enough in the following video record. But here, yes, at the view reading stage, don't forget, one more time say, little bit make it greater in size. And then, well, actually, let me open this file in Paint program. Can find a pencil over there. Okay. To draw something. Okay. Yes. Okay. Take this color and pen. Yes, don't forget, between the front view and the left side view, what we have z-axis. Between the front and the top side view, we have the x-axis. Okay. If you want, I may show the positive sense for the coordinate axis. Putting the arrow. This is the z-axis and this is the x-axis. This arrow to say that positive side of x-axis is to the left. Okay, and what is that? This is the y-axis. Okay, in constructing the profile view, we use the y-axis as oriented horizontally and the positive side extends to the right. But constructing the top view, we consider the y-axis as vertically oriented, and it is positive side is in the down direction. Yes, this is the arrow to say that y-axis. Be aware that we have such a coordinate system, and the transfer lines at the background, see the transfer lines. Yes, this is a transfer line. This is a transfer line, you see. Well, for instance, this feature which you selected on the view, yes, this part of the projection is between this transfer line and that transfer line. Since the views are consistent, then following those transfer lines, this and that, on the other side image, well, between the same transfer line, this and that, these two transfer lines, we must find the other side image of the selected feature. Okay, so thereafter be able to combine this view of the feature to that side view of the feature. And if you have one more view, then with that side view as well in your mind, and then combine these two projections in your mind, and then be able to say that that feature is in this shape. And seeing the associative dimensions can say that it is in that size. Okay, next video record, in the example you're going to see, while I'm passing to the stages, well, how I apply my view reading method. Yes. Similarly here, between the views. Yes. Between these views, take a pencil in this color, and then I hope can draw the line. Yes, between the front and the top, this is the x-axis, okay. Between the front and the left side, you say that this is the z-axis, okay. And between the well, the top and the left side, we have the y-axis here, and between the front and top and the left side view, we have the y-axis there. Y-axis appears on the page twice. Constructing top view, use this one. Constructing profile view, use that one. If there will be three views, of course, that is the coordinate frame. So, well, and then say, for instance, here, take a color, different color, and then, well, line thickness. For instance, here, well, select this part of the projection. If the object is little bit complex, well, not simple, that in basic shape, but it's a composite prism, composite object. So once having a look at, couldn't understand its shape, then use one tool of my method. It is what? Transfer lines. Okay, well, select this part of the projection. Okay, and then, well, for this, actually in my method, it is discretization. Divide the complex object into sub-portions. Well, I selected this portion as one of them. And then after focusing the attention to such a selected feature of the object, then for which see the transfer lines. In doing this, not all of the transfer lines, but I recommend, to save time and effort, the transfer lines, those passing through the limiting boundaries of the selected feature. Okay. Select a different color. Pink I selected, and then, well, you see this selected feature on the top view is between of, it is too thick, decrease the thickness. Okay. Now this feature, which I focus my attention onto this part of the projection and saying that it is one of the features, okay, is between this transfer line and that transfer line. Okay, the top view of the selected feature is between this and that. Since the x-axis is commonly used by this, by that, then, well, if the top view of the selected feature is between this and that, its front view must be between the same transfer lines. Within the region, it is bounded by the continuation of the same transfer lines, the continued part. So, well, be aware that it is so. Well, in other words, the front view of this feature can be found over there. Which region? It is a region bounded by the same transfer lines. So, to be able to find the front view of this feature, okay, well, between the transfer lines, see what you have. Between the transfer lines over there, correspondingly, can see the front view of the selected feature. I mean, if you know the ABC of orthographic projection and know that x-axis is commonly used and those are the transfer lines at the view drawing stage to use for having the top view here, having the front view there as consistent with each other, then you look for the front view of this feature, not here, not there. The front view of this cannot be this part of the projection. It must be in the region bounded by this and that. So this is the front view of that selected feature. And then, well, after passing to the consistency checking stage and saying that this is the top view, this is the front side view of the selected feature, then, well, deal with the rest. Okay, then, if it is so, what is the shape? Rectangle, rectangle. Okay. And then, of course, well, if you have one more view, then before saying something that it is in this shape, then don't forget to check whether the third view also verifies your imagination, your reading. Well, at this point, remind you what we have. We have let me take the same color. We have a mitral line, okay, and this inclined line, you know, its inclination angle is 45 degrees, is used to transfer the delta y values from top to left or vice versa. Well, here, after saying that, this is the front, this is the front, this is the top side, then, well, follow the transfer lines. You see the top view of the selected feature is between these two transfer lines, this and that. Since the y-axis here, y-axis there is used by this, by that, then, well, if the top view of the selected feature is between this and that, its front view must be between the rest of those transfer lines. After the intersection points along the mitral line, change the direction and then continue. While this transfer line continue in the up direction. So, well, if the top view is between this and that, left right view of the selected feature must be between this and that. Well, so, well, the left side view of the selected feature, this means cannot be here. It must be there. Where? Well, from the front view, okay, follow the transfer lines. Well, and then see the region. At the region which is bounded by this and that, these are the transfer lines to transfer the delta z value from the front view to the left side view. And this and that, these are the transfer lines to transfer the delta y value from the top to the left. So, well, you see these 4 transfer lines bound this region. It is the region, this region, to find the left side view. Okay, in this region, yes, what we have? Correspondingly, another rectangle. Rectangle, rectangle, rectangle. You see here we found a rectangle on the front view. Following the transfer lines, another rectangle on the top view, and these 2 rectangles correspond to one more rectangle on the third view, on the left side view. This means that feature is a rectangular prism. You see, the second part of my method is that discretization. I use discretization technique, divide the complex object into simple sub-portions in shape. And for each portion, ask the question, what is the shape? Of course, it can be answered while distinguishing it is views on the page. Which part of the projection, this projection, corresponds to the front view of that selected feature? The answer, you know, if you follow the transfer lines, okay, well, if the top view of the selected feature is between this and that, then this front view must be between the same transfer lines. Can say similar things, okay. For the left side view, if the front view is between this transfer line and that transfer line, then the left side view must be between those. And well, mitral line is over there, and top view is between this and that, these 2 transfer lines. So well, the left side view must be between the continuation of those, where at the region bounded by this, and that. Here it is the region to find the left side view. And over there we found another rectangle. So this means rectangle, front view is a rectangle, top view is a rectangle, left side view is a rectangle. So this means that part of the object is a rectangular prism. It is an extension from the front and the top, can see. And then start visualizing the object in the mind 3-dimensionally. Here is the rectangular prismatic extension. Okay. Observe it in this direction. See a rectangle, top view a rectangle, left side view another rectangle. So it's a rectangular prism. Here it is model. Yes, okay, well, I'm going to end this video record at this stage. And then the next video record, well, starting from the beginning of view reading, okay, step by step, pass through the stages, and you're going to see the tools of my method, view reading method, and then, well, complete the reading exercise. Have a break right now, and then after the break, see such an example, and then see what is my method, how it is applied, how the views can be read, okay, much more easily. The answer using the method of Murat Sönmez Hoca. Okay. See you after the break.